gravitational force plus work done by normal reaction plus work done by friction is equal to change in kinetic energy. The delta K we had deduced earlier to be 0. Work done by gravitational force is mgh. Let's write it down. Work done by the normal reaction is 0 and the work done by the friction will be negative mu mgs. Now let's go back to the question to identify which parameter are we supposed to find. We need to find height of the ramp, which is h. So let us try to make h as the subject. So in this expression, if I take minus mu gs on the right hand side, we will get mgh will be equal to mu mgs. M will get cancelled out from both sides and also G will get cancelled out from both sides. And if we make H as the subject, we will get mu S as the answer. And let's go back to the options. Where does mu into X exists? It is option D, and that is the answer for this question. So here we have a motor which is using a cable to pull a trolley up an inclined plane, but at a constant velocity. This is the keyword. So constant velocity means kinetic energy will stay constant. Which of the following statements about the energy changes are correct? So if we look at the three statements, the easiest one to analyze is statement number 2, which states that the total of kinetic and potential energy of the trolley increases. Is that right or wrong? Some students deduce that the total energy, which is called mechanical energy, which is nothing but the combination of kinetic and potential. So mechanical energy is always conserved. That is why option 2 is incorrect. That deduction has a slight flaw in that. So when we say mechanical energy is conserved, that is only conserved when no energy is lost to the environment, which means there are no resistive forces in the system. So there would be no friction, no air resistance, and that is why no energy is lost out. So in that case, we can say initial total energy will be equal to final total energy. But in this case, the trolley is being encountered by a downward friction. So mechanical energy will not be conserved. So the total of kinetic and potential energy being conserved, that's a wrong statement. But still, we need to check, is the statement 2 right or wrong? It states that the total of kinetic and potential of the trolley increases. Kinetic energy, first of all, is constant since the velocity is constant. So let me write kinetic energy is a constant. Whereas potential energy, the formula for potential energy is mgh. Now, as the trolley is going up, it is being lifted up, which means the value of h is positive. So potential energy is definitely increasing. Hence, the sum total of kinetic and potential also will increase. Hence, we can say statement 2 is definitely correct, which means now if you look at the options, we can eliminate option B since it does not have the statement 2. Statement 1 states that the work done by the engine has a greater magnitude than the work done by friction. Now, there are various ways to analyze it. So, we will start by drawing the free body diagram of the object. So, let's start. So, what will be the different forces acting on this object? One will be the weight of the object, mg, acting downwards. Then we have the normal reaction going this way. Tension will act up the string. Now, this tension is the result of the motor. Since the motor is doing the pulling, so we can say tension is nothing but the engine power. Apart from these forces, we have a downward frictional force, which will be acting down the plane like this. And now we can use the work energy principle, which states that the total work done by all the forces acting on the object will be equal to the change in the kinetic energy. And since in the question it is mentioned that the velocity is constant, which means the change in kinetic energy will be equal to 0. So all we need to do is figure out the total work done. So there are four forces acting here: normal reaction, tension, the gravitational force, and friction. So let us write down the total work done will be work done by the normal reaction plus work done by T, tension, which is the engine power. So WT stands for the work done by the engine. This plus work done by the friction plus work done by the gravitational force. Now we have incorporated all the four forces acting on the object, and the sum result will be equal to 0. So let's write this is 0. Now the formula for work done is Fs cos theta. So this can be used to, let's say, figure out the work done by normal reaction. So the normal reaction is this way and the trolley is going up the plane. So if you analyze, the angle between the normal reaction and the displacement is 90 degrees. So the work done by the normal reaction is taken as 0 because theta is 90 and cos 90 is 0. So work done by the normal reaction is equal to 0. So now let us write down the eventual expression. Work done by T, T although it is tension, but the source of tension is the motor, which is the engine power. So instead of WT, let me write down the work done by the engine plus work done by friction plus work done by the gravitational force. This is equal to 0. Now, if I go back to the statements, the statement 1 was the work done by the engine. We have to figure out the work done by the engine. So let us make WE as the subject. So we will get negative WF minus WMG. And let us make negative common. So we'll write WF plus WMG. Now, if we take the magnitudes only on both sides, so let's take mod on both sides. So the negative sign we will ignore. So the work done by engine will be equal to work done by friction plus work done by the gravitational force. These are the only the magnitudes. Hence, we can deduce that the work done by the engine is greater than the work done by the friction. Since in the equation we have WF plus something. The engine work will be greater than the frictional force. If I go to the statement 1, it states that the work done by the engine has a greater magnitude than the work done by the friction, and that is what we proved. Hence, statement 1 is also correct. In statement 3, it is saying the gain in gravitational potential energy of the trolley has the same magnitude as the work done by the engine. This is definitely not right. So, this statement would have been correct if there are no resistive forces acting on the trolley. So, imagine a case where friction were absent. In that case, the gain in GPE would have been equal to the work done by the engine. And to sum up, remember to solve questions like this, mechanical energy is always conserved if no energy is lost into the environment, which means no resistive forces are acting on the object. But if frictional forces are present, then we use the work energy principle because that formula also takes into account the work done by the frictional forces. And hence, now if we look at the options, statement 1 and 2 are right. So option A is the right answer.